In this video, we will see how to take a simple design and implement in DE1 SoC board, which is available in Labsland Platform. First, you have to download Intel Quartus Prime Lite Edition. I provided the URL in the description. Once you install, you'll be able to open Intel Quartus Prime. The first step, we have to create a project. So to create a project, click on File and click New Project Wizard. So you'll get a pop-up window. So in this new project wizard, we basically will provide a project name and we'll identify the directory where all the project related files will save, and we'll provide the top level design entity name, and we'll choose the target device, and if required any additional EDA tool settings. Just click set text. Now you can choose the project directory path. Then can provide the project name, which in turn the top level entity name. Click next. Now you can see the two options. One is the empty project, the other one is project template. So this project template option will take you through the design store, where you can take some of the existing design template available on the design store. Right now we will be choosing empty project. Click next. If you have any design files in this wizard, you can add a Verilog or VHDL design file. Since we are going to create our design file, you can skip this and click next. Now under the family and device board setting, so you will be able to see there are two options. One is device, the other one is board. So right now we are going to choose the board, and the target board which we are going to choose for this demonstration is DE1 SoC board. Just choose DE1 SoC board and click next. Any additional EDA tool settings that you require to complete this project? I don't require any additional EDA tool settings. I can just give none and click next. So now you can see the summary, the project directory, the project name and top level design entity name. And for the DE1 SoC board, there is Cyclone 5 device, and the device detail is available here. Just click finish. Now you will be able to see the device detail and the project name under the project navigator. Now we need to create a design file. To create a design file, click File, New. Now you can choose Verilog HDL and give OK. So now you can write the design. When you write a design in Verilog, the module name should be similar to the name of the project. So you can write the Verilog code in any level of abstraction, like data flow or gate level or behavioral level. In this example, I am writing the design in data flow level. Once you write the code, then you will be able to save this using this save tab, and which will be saved with .v extension file. Once you save, you can compile it using processing and start compilation. So this compilation will take you through the various steps like analysis and synthesis. The analysis part basically check for any syntax error, and synthesis will convert the RTL code into a gate level netlist, mapping to the device primitives available in the library. Then the fitter basically target to the Cyclone 5 device, and it will use a logic element, and then it will realize the given functionality into the target logic element, and which in turn interconnect with IOs. And finally the assembler will generate the bitstream file format which we'll use for implementing to the target FPGA. And you will be able to see the progress here in terms of percentage. So now 100% the processing is completed, and you'll be able to see the message here, the full compilation was successful with 0 errors. Now the next step, we need to map the design inputs to the device inputs and the design output to the device output. So we need to make a pin assignment. So to make the pin assignment, you can use a TCL file. So this TCL file link I provided in the description. So you can use the switch 0 and switch 1 as input, and LEDR 0 and LEDR 1 for the outputs. So now just copy paste this and just replace SW0 and SW1 with A and B. So now switch 0 is mapped with A and switch off 1 is mapped to B. Similarly, you can map LEDR 0 with sum and LEDR 1 with carry. So it is case sensitive. You have to be very careful when you are assigning the pin names. So whatever the design pin names that you have provided in Verilog code, you have to use the same name, and it's case sensitive. Now select and copy, and in Intel Quartus Prime window, you can find TCL console. If you're not getting this TCL console, you'll be able to get that under View, Utility Windows, and TCL console. Okay. So now just paste that in TCL console window, and now it get mapped to the respective pins. How we can ensure it? Just click on assignment and then assignment editor. Now here you can see this. A, B, S and C is being mapped to the respective pin location. Now after mapping the pin assignment, again we have to do a full compilation as we did earlier. Click on processing and start compilation. So in this compilation, we have made a mapping to target Cyclone 4 device. It will use the logic element resource accordingly and map the IO connectivity. And this will be the final bitstream file format generated by the assembler, which will use to target FPGA to program it. Now the programmer is successful. You'll be able to see the message here. Now to implement in DE1 SoC, as I told earlier, we are going to use Labsland Platform. Now you can see this Labsland Platform. I provided this link in the description. So being a first time, you can click on it's my first time in Labsland, and it will ask for the sign up. You can do the procedure, and once you sign up, the login credentials will be available to you. Once you get the login credential, next time you can click on I have used Labsland before. So provide the login credentials which you have created. and now you'll be able to see this DE1 SoC board. Click on access this lab and click on access. Now you'll be able to see this window where the DE1 SoC board is made available to you, right? Now you can see on the right hand side, choose file. Now you need to browse to the directory where your project folder have been kept, and you will be able to see under the project directory half header output files, and you can see this .so file, which is SRAM object file. Just open and upload. So now you can see the switch made available here and keypads made available here, and in our design we mapped switch 0 to A and switch 1 to B. Now both are 0 0, and in the output the LEDs are not glowing, right? It's 0, so it's logic 0 0 according to the truth table, both sum 0 and carry 0. So now I'm making 0 1, right? So when I make 0 1, you will be able to see the output. Okay, the sum is 1, carry 0. And when both are 1, you will be able to see this sum 0, carry 1. So you can check all 4 basic combination here. So there will be a little delay will be available because we are connecting to the remote lab. And you can see the timer running here. So once you verify the logic, you can just click on leave now. So that's all. We have learned how to take a simple design and implement using DE1 SoC board available in Labsland. Thank you.